Dear viewers, welcome to the YouTube channel H2O Chemistry. So in our last video, we have seen the elements and its classification. In this video, we are going to see the properties of elements. We are going to compare the properties of metal and non-metals. My dear students, I strongly recommend to you, when you study the properties of metals and non-metals, compare the properties and then learn. It will be easy for you so that the property is just opposite to the metals and non-metals. So I recommend you to compare the properties and learn. So what is an element? Element is made up of similar kind of atom. So far we have around 118 elements in our earth crust, and we have classified into metals, non-metals and metalloids. So this we have discussed in our last video. So in this video we are going to talk about the properties. So look at this periodic table one more time. Most of this, so all this orange color, green color, pink and violet and this blue color, all are made up of metals. All are metals. So most of the periodic table occupied by metals, and some of the yellow color is a non-metal and the noble gases, and this is a green color, light green color, is nothing but metalloids. So this is what we have discussed in the last video. So let us see some properties about metals. You could see the properties, physical state of metal. Generally metals are solids. Look at this. It's a sodium. Sodium is a solid, you can see. Usually they are solids except mercury. Yes, you are right. You could see the periodic table. Mercury is given in a green color. This green color indicates nothing but liquid, right? So understand that the mercury is a liquid in state. It's an exception. Some of the other metals like gallium, cesium melt below 30 degrees centigrade. You could see this GIF file. You could see the gallium metal with that temperature of our body. If you keep the gallium metal in our hand, a solid metal, that will melt automatically by absorbing our body temperature. So it's a solid but readily melts when you hold it. It absorbs our body temperature. So it's around 30 degrees. They may also be in the liquid state. And what about non-metals? Non-metal physical state, they are available in all the three states. Mostly they are in the gaseous form. For example, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine. One of the non-metal is bromine. Look at this bromine. Bromine is available in a liquid state. You can see this orange color. So this is a non-metal bromine which is in liquid state. The solid state like carbon, phosphorus are the examples, sulfur are the examples of non-metal which are available in the solid state. Come to the density. Usually what is called density? Mass by volume is called density. Usually when you hold a metal, we feel heavy. Like if you hold an iron, we feel heavy because in the particular unit volume, a lot of atom is packed. That's the reason their mass is high. When the mass is high, density is also will be high. Density is also high. So they usually have a high density except the sodium, potassium and calcium. So you could see this, the sodium metal is somewhat soft. We can easily cut it with our knife because the density of the metal is less. This is an exception. Sodium, potassium, calcium are exceptions. What about the non-metals? Non-metals, the metals have high density, obviously non-metals will have a low density. So what we have to understand, if metals we say high, non-metals obviously will be in lower side. The density is usually low because the number of atoms present per the unit area will be less. That's the reason mass is less, so the density will be less. Now, what about the melting point and boiling point? Include the boiling point as well. Look at this diagram. It represents melting point of some metals and some non-metals. You could see the green color, we say melting point is given in Kelvin scale. Similarly, the boiling point which is given Kelvin, with red color it indicates. Look at this. Green color alone we will compare for sodium, metal, magnesium, aluminium, silicon. So for all these comparatively, so sodium, magnesium, aluminium, all these are metals. Phosphorus, sulfur, chlorine are non-metals. Compare these three values with this. Obviously the aluminium, magnesium, sodium is high, so they have a high melting point. What about boiling point? Obviously you can see the boiling point of aluminium is above 2500 degrees centigrade. The phosphorus, sulfur, chlorine all very less when compared with this metal, right? So the melting point of or boiling point of metals are usually high. What about non-metals? They are usually low. Exceptions, some exceptions like mercury, cesium, gallium, tin, lead. I told you gallium which will melt at our hand. So they have a less boiling point, less melting and boiling point. Come to the next point, hardness. What do you mean by hardness? Hardness. So it's one of the property of metal. If you hammer it, doesn't break. They we say hard and strong. See, the metals are usually hard because when you hit with something, they don't change their shape. When you apply a lot of pressure, they change their shape. So they usually hard. But exception like mercury, sodium, calcium, potassium, because they are very soft metals, we can easily cut with a knife. So they are soft. Other metals are hard. What about non-metals? They are not usually hard, that means they are soft, but the exception is diamond. We know very well that diamond is a very hard substance, a very rigid substance. Diamond can cut diamond. It means the diamond is a very hard non-metal which is made up of purely carbon. Carbon is a non-metal. Carbon is a non-metal. So diamond is made up of purely carbon, so which is a non-metal, which is a very hardest substance ever known. And come to the next property called malleability. Malleability means malleable means we can beat into sheets. That's what. Just see this gold. Gold is most malleable metal. Malleability. Metal hammered into a thin sheet. When you hammer it, the atom will align and differently align so that the metal can be made into sheets. You could see the aluminium or iron, you can make sheets by beating. So this property, so what is called malleability? Beaten into thin sheets. This property is called malleability. Generally, metals can be beaten into sheets. Here we have iron sheet, gold sheet, aluminium sheet, lead sheet. There are many like that. So that means they can be beaten into sheets. But non-metals, they are generally brittles. When you take sulfur, phosphorus, carbon, when you break it, we can easily break. Exception is again diamond. But the other form of carbon, if you see, like graphite or coal, charcoal, all we can break easily. The next property is called ductility. What do you mean by ductility? You could see this picture. Ductility. Ductility. So drawn into wires. So this is they are making wires from gold. So we can drawn into wires. This property is called ductility. So all the metals can be drawn into thin wires. Exception like sodium, potassium, calcium or less hard, okay, very soft, and have a very least density, so they break when they drawn into wires. So drawn into wires, this property we call ductility of metal. Usually the metals can be drawn into thin wires, so metals are ductile. What about non-metals? They are non-ductile, so they cannot be drawn into thin wires. Come to the surface hardness. I told you about hardness. Look at this chart graph. We can understand diamond has a most surface hardness than any other metals like stainless steel, titanium, steel, copper, aluminium. So diamond has a very high hardness, remember. Now what is called as tensile strength? We know very well that when the bridge making process, so when the bridge is built, you could see the large concrete blocks can be lifted by chains. Usually the chains are made up of metals. So the metal can hold high weight. That means a very large amount of weight, because they have a high strength, tensile strength we call. So metals usually have high tensile strength, exception zinc, mercury and gallium. They have a low tensile strength, but other metals have high tensile strength. That's why we use it for construction purposes and other machineries, industries like that. What about non-metals? The tensile strength of non-metal is very, very less. But exception is carbon fibers or carbon nanotubes we call, which are very stronger than steel. So carbon nanotubes. Carbon nanotubes are exception for this case, tensile strength. Come to the next property, conduction of heat and electricity. Metals usually a good conductor of heat and electricity because each metal atom is linked with other atom. They can pass their electron to other atoms because they arranged in a very close manner. So the electron of one atom can be transmitted to another atom. So in that manner they shift electrons, they conduct heat and electricity. So when you heat a spoon, the heat can travel from the one end to another end by transferring the electrons. The electron will gain that energy and transfer from one atom to other. So by that time, when you, for about few times, okay, little later, we could feel the heat. It means the metals are good conductors. What about non-metals? They are poor conductors of heat and electricity, but there is one exception, that is graphite. Graphite is a very good conductor of heat and electricity. We're going to see some other properties like lustrous, which means shining. Look at this picture, copper, silver, iron, gold, all are shining. It means metals are luster, so they have this luster property. What about non-metals? They are non-lustrous, so they do not shine. Exception we can say iodine, which has a shininess, so we can say iodine is a lone luster property. The next property is called sonorous. So when you hit with other metal, it produces a particular sound called cling. This particular sound is produced usually by metals. So metals are sonorous. This means they produce a ringing sound when they hit. This property allows to be used for making bells. You could see the bells, drums, okay, other things we can make out of this. So these are the property we say for metals and non-metals. So compare the property and then study. So it will be very easy for you, my dear children. You can understand the concept very easily. So physical state, generally usually solids. Mercury is a liquid. Gallium, when you hold it in hands, it melts. Usually it's a solid. Non-metals, mostly they are available in 3 states: liquid, gas, solid. Only one non-metal is liquid, that is bromine. Density, they have high density, they are low. Melting and boiling point, metals have high melting and boiling points. Non-metals, they have low melting and boiling points. Hardness, usually metals are hard, non-metals are soft or not hard. Malleability, so the metals are malleable, non-metals are non-malleable. Ductility, metals are ductile, non-metals are non-ductile. Tensile strength, metals have high tensile strength, non-metal do not have high tensile strength. And conduction of heat and electricity, they are very good conductor of heat. The metals are very good conductor of heat and electricity, whereas the non-metals are poor conductor of heat and electricity. Metals are lusher, metals are sonorous, but non-metals are non-lusher and non-sonorous. So this is the small recap about the properties of metals and non-metals. So this is a simple area. You could remember the points alone. Some exception will be there that we can just look at it so that you can understand more better about this idea. Thank you, my dear children. Keep watching. Subscribe for more videos. The chemistry concepts made easy here. Thank you.